Hello again, my name is Tico. I'm a student at Lambda School. I'm creating this 4-part tutorial for any students struggling with BFS or DFS or graphs in general. I struggled with them myself when I was going through the computer science portion of the curriculum at Lambda School, and I just wanted to help other students that were also struggling with it and also wanted to solidify my knowledge on the material. So here we go. So this is the second video. We're going to talk about stacks as the other data structure that's going to be used in BFS and DFS. And I don't mean stacks as in stacks like on deck or anything like that. I'm actually talking about stacks, kind of like pancake stacks. Not exactly, but it's a cousin to the other data structure we talked about in the previous video, the queue. The stack is another linear data structure that can be used to hold items. It's very, very, very effective at holding items and making them easily accessible using the push and pop method. But anyways, we're going to talk about how items go into the stack and how they come out of the stack. So let's put some items in here. Just a bunch of X's. So in Python, a stack can also be represented using an empty array or a list. And if you want to have a better visualization of how that stack works, with a stack of pancakes, and if you want to view this array in a way that's similar to how we have these pancakes arranged, imagine your array like this. And here's the front of the array. Here's the back of the array here. Okay, so it is literally just turned 90 degrees to the left. So items are always added to the top of the stack, and they always leave from the top of the stack. Same way that you would like cook them and put them on there and then eat them and take them off if you're a normal, regular person. Okay, so now we're going to define the stack class. Here we go. So, very similar to the queue class, the stack class is going to have 4 methods on it. And you guessed it, the first one is the init method, which allows us to initialize an instance of the stack. That's going to take in one parameter, just self. And just like the queue we saw, it's going to be self.stack equals that empty array we talked about, right? That's how a list, or a stack is represented in Python. All right, the next method. Now we want to add things to the stack. How do you think we do that? You can't use the enqueue method. That's how queues get things added to them. We need to use a different method. We are going to use the push method. And that's going to take in 2 parameters. The first parameter is self, second parameter is value. That's the value that you want to add to the stack. So let's draw a stack. Okay, so if we want to add an item to the stack, we have to remember LIFO. Last one in, first one out. Just like a stack of pancakes. Alright? So an item, if we add it, it'll add to the end of the list. Okay? And so the way we're going to do that is we're also going to use the append value here, the append method that we did with the queue class. So we put self dot stack dot append, and we're just going to pass in value there as the parameter for the built-in append. That's good. Cool. All right. Next, we need to figure out how we're going to take items off the stack. Right. So if items are coming in the top of the stack, they're also going to leave from the top of the stack. If you go to Disney World and you get on a ride, the way that the queue works is you wait at the end of the line and then you leave the front of the line to get on the ride. I have a friend, Julian Moreno, good friend of mine, also a Lambda School student. If you're looking for a UX designer, holler at him, he's good. He has a Disneyland yearly membership, and he's able to get the Fast Pass, which will allow him to wait at the end of the line, enter in the end of the line, and then literally get on the ride from the end of the line. That is what a stack does. That's LIFO. That's last one in, first one out. That costs money, but it's LIFO. LIFO. All right, so how are we going to do that? We are going to define the pop method, and that's just going to take in one parameter called self. And same as we did with the queue, we need to make sure that the stack is not empty. So we'll need to use the if statement to validate for that. So we're going to say if self.size is greater than 0. So if the stack isn't empty, we'll do the following. So we're just going to return self.stack.pop, and we won't pass a value inside of that built-in pop method. Why? Because if we pass in a value, then it's going to specify an alternate spot from where we actually want it to take from. So this pop method naturally, or defaults at taking items off from the end of the list. Whereas in the DQ method we also use the pop method, but we pass in the 0 parameter for argument there, so that it would pull from the front of the list, but we want it from the back of the list. Okay? And now we're going to need an else statement here to handle any cases where the stack's going to be empty. Because remember, you can't remove something that's not there. So we're just going to return none, just like that. And then the last method we'll talk about is the size method, which you can see is utilized right here. So we're just going to do def size, and we'll pass in one parameter called self, and we'll just return the length, which is built in Python method, of self.stack, just like that. And there you have it. That's stack, ladies and gentlemen. Thanks for watching.